If you're running delivery operations at a 3PL past a few million parcels a year, you already know where the bottleneck is. It isn't the warehouse. It's the delivery management layer sitting between your operational systems and the carriers. Inconsistent event data, sprawl and integration debt that compounds with every new client you onboard. This 5-layer reference architecture for enterprise delivery management explanation is for you. In the next 9 minutes, I'll walk you through a 5-layer reference architecture for enterprise delivery management, where it breaks in production, how nShift's products actually fit into it, including where they don't, and a checklist you can take into your next vendor evaluation. The 5-layer reference architecture. 5 layers, bottom to top, each one a separate concern you can evaluate, replace, or extend on its own. The 5 layers, bottom to top, are as follows. Layer 1, your systems of record. Layer 2, carrier connectivity. Layer 3, event normalization. Layer 4, the control tower. Layer 5, data and analytics. Layer 1 is your systems of record. The WMS triggers shipments, the TMS hands off transport plans, the ERP pulls reconciliation data back, and the OMS feeds order context. 4 systems, and they rarely speak one protocol, so the platform has to handle API, EDI, file feeds, and event-driven messaging at the same time. The question isn't which protocol it supports, it's whether it supports all of them without forcing your stack to compromise. Layer 2 is carrier connectivity. This is where most platforms either earn their keep or fall apart. Pre-built integrations to every carrier your clients use, label generation, manifesting, pickup booking, pre-integrated carrier counts get the marketing attention. But the harder question is, who keeps those integrations alive when carriers push breaking changes, which they do constantly, often with minimal notice? Layer 3 is event normalization. Every carrier sends tracking and pod events in its own format, on its own timing, with its own completeness. One carrier sends 15 status codes, another sends 3. Without a normalization layer, every downstream system has to handle every carrier's quirks independently. Build it once, and you get one definition of delivered, one pod record, one consistent stream feeding everything downstream. Layer 4 is the control tower, the operational workflow layer. SLA monitoring across carriers, exception management, automated routing decisions when a shipment is at risk. It turns event data into action. Not every vendor uses the term control tower, some call it operations dashboard, exception manager, or workflow engine. The label matters less than whether the capability is actually there. Layer 5 is data and analytics. A unified data model exposed to BI tools, ML pipelines, and downstream systems. This is also where AI capabilities increasingly land. Predictive ETAs, anomaly detection, and automated exception triage. The quality of this layer depends entirely on Layer 3 being right. Garbage events in, garbage analytics out. Where it breaks in production. At enterprise volume, 4 failure modes show up daily. Evaluators miss them in demos and discover them in production. The outbound path is the easy half. Outbound, the WMS triggers a shipment, the delivery management layer books it and labels it, the carrier collects it. The hard half is the return path. Tracking and pod events flow back from the carrier, and that's where data goes missing. First, webhook drops. Carriers don't guarantee event delivery. Some send retries, some don't. Some send duplicates, some don't. If your platform isn't running a reconciliation job that polls for missing events and dedupes duplicates, your tracking is incomplete and your reporting is wrong. Second, a carrier API goes down mid-shift. With no fallback routing and no retry logic, shipments stall while operators watch. The platform has to fail over or queue and retry in seconds. Third, rate limits. Peak periods hit carrier API ceilings. Without queue management and back pressure, it drops requests or melts down. Fourth, unknown event codes. Carriers introduce statuses without warning. Log them, surface them for review, and keep the rest of the stream flowing. These aren't edge cases. The architecture has to assume failure, because failure is the steady state. Now let's map this to a real product set. I'm going to use nShift as the example, but I want to do it honestly, which means flagging up front that the mapping isn't tidy. Some layers have one product, some have multiple, and they overlap. One layer doesn't have a dedicated product at all. That's the reality of any platform at this scale. Let's explore a working scenario, a Nordics-based retailer fulfilling out of Sweden, the UK, and Germany. Around 40 carriers in active use across those three markets. A mix of B2C parcel and B2B pallet flows. Layer 1, systems of record. Integrations aren't a single nShift product. They're a horizontal capability across the platform, connecting to your WMS, TMS, ERP, and OMS through APIs, EDI, file feeds, and event channels. Layer 2, carrier connectivity. Two products live here and they overlap. nShift Ship is the enterprise carrier network, over 1,000 pre-integrated carriers. nShift Delivery is the self-sign-up version for SMB and mid-market. Most enterprise 3PLs land on Ship. For the B2B pallet flows, nShift TMS sits alongside, handling transport planning. Layer 3, event normalization, is nShift Track, which handles carrier tracking events and pod evidence, normalized into a consistent schema across the carrier network. This is the layer that lets you ask, "Show me everything delivered yesterday," and get a meaningful answer regardless of which carrier handled which parcel. Layer 4, the control tower, has no single product. The capability is built across Track, the integration layer, and the customer's own tooling. Layer 5 is nShift Data Fabric, where Track and Ship data converge into a unified model. Anyone selling you a tidy one product per layer story is selling you a slide, not an architecture. Sitting on top of the architecture, consuming from it rather than part of it, are three customer-facing products. nShift Checkout for delivery options at the buy moment. nShift Track for branded post-purchase tracking. nShift Returns for self-service returns initiation. These aren't part of the 5 layers, they're consumers of them, which means they only work as well as the layers underneath. A polished tracking page on top of a broken normalization layer just shows broken data faster. Take this into your next vendor demo. 6 categories. The questions in each are designed to expose weak architecture inside 30 minutes of conversation. First, carrier connectivity. How many carriers are pre-integrated by market? Who maintains them when carriers push breaking changes? What's the SLA to add a carrier that isn't in the library? Second, system of record. Which integration patterns do they support? Is there a pre-built connector for your WMS, TMS, ERP, and OMS? And if it's custom, what's a realistic timeline? Third, event normalization. Can they show you the actual normalized schema? What happens when a carrier introduces a new code? And is there a reconciliation job for missing webhooks? Fourth, the workflow layer. What's built in versus configurable? When a shipment breaches its SLA, what's the workflow? Can your ops team build rules without an engineering ticket? Fifth, proof of delivery. Does it normalize signature, photo, and GPS across carriers? Is the pod record exposed to your ERP, and how long is evidence retained, and where is it stored? Sixth, the data layer. Is there a unified schema for cross-carrier reporting? Can your BI team query it directly? And what's the event-to-data latency? Vague answers are warning signs. The platforms that scale answer them in specifics. The ones that don't, dodge them entirely. That's the architecture, the failure modes, the product mapping, and the checklist. For a deeper architecture walkthrough, book a demo using the link in the description, or drop your questions in the comments.